Okay, what we're going to do for today for lab is, lab 12 is the motion analysis. So first, Larissa's going to go over a few things of the simple, how to connect joints, how to make drivers and everything to set up the motion. And then we're going to do the lab that's included in the tutorial that's included in the lab document, which is when you run the simulation. That's the one that we'll do. The stuff Larissa's going to talk about is not, you don't have to do that tutorial and turn it in for the lab. That's just reference material, because you're going to need to know that, because also as part of the lab you do a motion simulation of some subassembly in your part. So you're going to need to know how to set it up, if that makes sense. But the specific any tutorials or anything she's going to do is not something to be turned in. You don't have to turn it. It's just good reference material. So she's going to go over the basic setting things up, then I'll do the tutorial, which is in the lab, and then at the end I'm just going to go over real quick a few things about visualization, just how to make your parts look a little bit better, so you can save good pictures of them in the nets. That's what we're going to do for the lab.
All right, so a quick intro on motion simulation. There's two types of motion analysis that you can do. One is kinematic. That does not include material properties. That's just for visualization purposes. Like, I just want to see this thing move. That's kinematic. If you want to do dynamic, you can start to get things like loads during the motion and more detailed results, like moments of inertia, things like that. You can input that information and get results back. So it's more of a analysis type tool versus like just a visualization thing. And these motion simulations they'll kind of make or break along with the visualization, like the rendering and things like that, they'll kind of make or break your presentation. So pay attention and it'll make your presentation look really great. So with the motion simulation, we're going to start off first by defining. You open up an assembly, something that moves, and define your links and your joints. So that's all that I'm going to go over. It's really simple. It's not that complicated. Let's see. Okay. So I just have the tutorials that I'm just going to be walking through a tutorial, but it's not due for lab. So just watch and it's pretty simple. Okay. Okay, so if I had just opened up a sub-assembly, this is just a 4-bar linkage, and let's go, so up in Start, same place where you go to Advanced Simulation, you go one more down, there's Motion Simulation. Okay, so here we are. There's a couple simulations. I'm just going to create a new one so you can see the process. So right-click on your assembly in the Motion Navigator, and we're going to do a kinematics analysis. We just want to see this thing move. We're not going to do loads or anything. Eric will go over that portion a little bit more. Okay, so, all right, so in this simulation, up here at the top, you'll notice in the toolbar, we've got links and joints. So anything that moves is a link. If it doesn't move, don't make it a link. So we have 3 links. This green base is going to be stationary, so it won't be a link. So we're going to make this one, just click on it. And then for mass properties, because we're doing a kinematic analysis, not a dynamic, we're going to change this to none. So we'll hit OK. So you'll see we have link 1 that showed up, so I'll finish making the last 2. It's already at none, so there's that one. Then we'll do this one. Okay. So now that we have links, we need to define the joints. So we need to tell NX how these things move relative to each other. So you just go to Joint, and there's several different types you can make under the Definition tab. Just pick the type, and you can see there's slider, cylindrical, like a spherical or a universal joint, and they each have their own, different geometries that you need to select in order to define the joint. But we'll just go to revolute, it's a really easy joint, and we'll select, in order to select the link, we could just select the link right here, but I can actually define all three of these if I select a curve. So I'm going to go in and select the inner curve of arm 1. That's the light blue part. So I select that edge, and you'll see that it automatically defined my origin, and it defined the z-axis. You can see right here is going right through that cylinder. So we'll hit apply, and you can see the little image popped up for my revolute joint. And we're going to just do the same thing with, let's see, down here as well. Okay, so edge in arm 1, grabbed it again, we'll just hit apply. Same thing up here, really similar process. Oh, I don't know what I selected. Looks like it got it okay though. Okay, so apply. So we've got all those joints. We'll do this one down here. So just grab that edge and hit apply. Okay, so we've got 4 joints, and you'll see those right here. We're going to make this joint, let's see, no, our second joint, sorry, this one down here, we're going to make it a driver. So it won't move until we give it a driver or tell it how it's going to move. So just right click on that joint and say edit. And then up here, you'll notice there's another tab called driver, and this will give it some motion. So we're just going to have it rotate. For this one, we're going to do harmonic rotation. It just kind of goes back and forth between the specified, like, according to the parameters here. So I'll do 90 for the amplitude and 360 for the frequency, and it's just going to move back and forth. We'll hit OK, and you'll see that big arrow pop up. So that's a driver now. So this thing's ready to go. Oh, not quite. Need to define a solution. So just like in motion simulation, just right click. There's a ton of options. Just go straight down to new solution. And all the defaults are fine. So what we have here under time and steps is we're going to show 50 frames. That's the number of steps in 1 second. So that's those are the results. And you can change that to be whatever you want. I get my animation toolbar to pop up. Okay. Oh. Where's the conversation?
It's this black right here.
Oh, okay.
Just right click and say invite to conference.
Okay, cool. Thank you. Okay, so we should be ready to go. I don't know. I'm trying to get this out of the way. This happened yesterday. What did I do? What did I do last time? Sorry, my computer froze, or NX froze. I ran into this yesterday. Cool, thanks. Okay, so we should just be able to right click and solve this thing. Please use dynamics. Oh, I might have, let's see. Okay. Just a second. I'm going to go into one that I did successfully yesterday. Let's see. Or maybe I didn't. That should work. Since that one didn't save anything. Oh, that's right. Okay. Okay, sorry, I forgot to select one thing. When I'm defining the joints, you need to go and select your base. This is the part that it moves like relative to. So for this first joint right here, we're going to select the blue, just any geometry on the blue part. We'll say okay. And same with this one. Right here, we'll select any geometry on the blue part as well. So go down to base, select your link. Okay. And then with joint 4, I think we're okay there. Let's see if that worked. Okay. Cool. This warning here is fine. It's okay. So you just hit play and it runs. You can just have it loop. I guess you could have it loop in your PowerPoint presentation if you want it to run continuously. And you can change the speed, and there's a few more options over here. Those are for more detailed analysis. So if you want to export a video, do you want me to do that now? Okay.
This is important too, because you're going to have to turn in video. Do you want to just tell them the microphone as well? They're going to have to turn in the video.
Yeah, so for lab, what you need to turn in is the tutorial that Eric is going to do, and also a movie of something from your part that's moving.
Tutorial as well.
And
Tutorial as well.
right.
Tutorial parts of something.
A video of the tutorial and a video of something in your car moving. So I'm done. So I hit stop to exit the animation, go to File, Export, and then there's different, while you've got your simulation open, just select, what type. Usually animated GIF works well, or you can do an MPEG video. You should have 51 frames. So remember, that was our setup from before. If you preview, some of the links go away. That's okay. They still get exported in the video. That kind of scared me last night, but they still go. So specify file name, just give it a spot to save it to. Just go save it wherever. Just show you that it works. Okay. Just hit okay. It's generating all the frames, rendering each one, and then we'll go find out, make sure it worked. And that's about it. Get that to pull up just a second. I don't know what that is. Okay, so there's my movie. It's really short. It's just 1 second long. But you can have it loop or change your options. Are there any questions on what we did for that portion? Any of you have any questions? No? Great. Okay, now Eric's going to do... Oh.
Someone on Tamberg have a question or Skype?
Larissa, just one comment. All of the other joints, the spherical joint and some of the sliding joints and things like that, they're very well documented in the NX documentation.
Mm-hmm.
So even though we haven't taken the time to kind of go through anything other than a revolute joint, they are very well documented in the online documentation.
Yeah. That's right. And we have several tutorials posted on TCC in the Lab 12 folder that are helpful as well. So, okay.
All right, thanks. Okay, now I'm going to go over the tutorial, which is on included that the lab talks about. So this is the one that you will be required to turn in. So let me. Okay, so just make sure we have those files.